Welcome to Vention Tips. Today, we'll be covering numeric variables and conditional loops, an expansion on the basic loops introduced in a previous video. For today's tutorial, we'll be using a 3-axis Cartesian machine. Devices such as these are often used in pick-and-place applications or even for material deposition. For this tutorial, we'll assume that the primary function of our machine is to deposit glue around the edge of a poster board. If you'd like to follow along, you can find the design link in the description below. This session will be broken down into 3 main parts: numeric variables, updating variables, and conditional loops. Don't forget, you'll need the machine motion controller in your design before getting started. We'll start by navigating to the MachineLogic editor at the top of your screen. As you can see here, we've pre-configured the machine. However, if you'd like to learn more about how you can do this yourself, you can refer back to our video on programming linear actuators found below. On top of this, we've pre-assembled a basic application that includes a homing sequence as well as a sequence that will have the Cartesian system follow a square path. We'll build our basic application in the main sequence and press play to see it run. With the basics complete, we can get started. Part 1. Numeric Variables. Numeric variables give you the option to create referenceable and updatable values, allowing you to build more configurable MachineLogic scripts. The Variables section can be found under the application name in the left pane. As you can see, there are 2 types of variables you can have: basic variables and inputs as variables. In this session, we'll be focusing on basic variables. We'll start off by creating 2 new variables that we'll be using in our square path sequence by clicking Add Variable. We'll call them Origin and End. These will represent the position of the corners of our square board. From here, we'll go to our square path sequence and replace the original input values of our moves with our new variables. To do this, simply begin by typing the variable you would like to use, and the available options will appear below the window. We'll select Origin for the 2 moves that will trace the first half of the square, and End for the 2 moves that will close the square. Now let's go back to our main sequence and press play. You'll see that the machine is executing the same path as before. However, this time, it's referencing the variables we'd created for these moves. Part 2. Updating variables. For the remainder of the video, our goal is to have the machine follow a rectangular spiral path, as in practice, this would be a great way to ensure even glue placement along the back of a board. To do this, we'll need 2 new commands, but before doing so, let's create a copy of our path sequence by right-clicking on it and selecting Copy Sequence. We'll rename our new sequence Spiral Path. In order for us to create a spiral path, we'll need to be able to modify our corner positions as the path is being traced, or put simply, update the variables. To do this, we'll click on Add command and select Set Variable. This command allows us to change the value of our variable throughout the program. In this, we have 3 options: from an expression, an external input, or from the actuator position itself. If you'd like to learn more about each of these, you can click on the Help icon above the drop-down menu. In our case, we'll be using from expression. This allows us to update our selected variable through a mathematical equation. For this command, we'd like to update the variable origin. For our sequence, once we've traced our initial path, we'd like to modify it by making it smaller, therefore creating the beginnings of our spiral. To do this, in the expression field, we'll take our current value of our origin variable and subtract 50 from it. We'll do the same for end, but instead add 50 to it. This will keep our spiral centered on our board. Once complete, we'll go over to our main sequence for the final step. Part 3. Conditional Loops. Now that we've created a sequence that traces a single revolution of our spiral, we need to build a program that will trace it fully. The command best suited for this is the loop command, so we'll add it to our main sequence and delete the original execution command. If we know how many times we'd like to loop our sequence in order to create a spiral, we can use the count option. However, it is more flexible to use a while condition. This will check the created condition, and if satisfied, run the sequence. Once finished, it will recheck the condition and run again if it's still satisfied. This will continue until the condition is no longer met. In our case, we'll have the loop check that our origin variable is greater than our end variable. With a statement like this, we could even change the size of our poster without having to do anything else, and a perfect spiral path will be created each time. Finally, we'll select the sequence we would like to loop and press play. To showcase the power of variables, we'll edit our created variables to 450 millimeters. We'll now press play and see how this has changed the behavior of the machine. As you can see, the machine now begins with a smaller path, but still executes a spiral shape based on the condition set earlier. That wraps up our session on programming using numeric variables and conditional loops. Thanks for watching, and happy designing!